Hello, welcome to not Mindset Monday at all. Welcome to the Happy Maths Hour. And I'm here with Toni, and we're going to talk about it. We did it last week. We're going to do it again, and I've got to say it again. Algebrarea. Say that fast. Algebrarea, 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 Algebrarea. What's so special about Algebrarea? Well, Algebrarea is algebra.
Well,
hold on, Toni. Wait. Hold on. Algebrarea is area and algebra, but it's magical. It's wonderful. You've got any problems with algebra as one of those flag words, you join us after the break, and Toni is going to take us through it at this amazing method, amazing concept of how to really get to grips and to enjoy algebra. See you after the break. Welcome to Happy Maths Hour with Algebrarea, and the amazing Toni Beardon is going to share what really is a great solution to introducing algebra, understanding algebra, and really importantly, overcoming both the fear and the confusion that exists around algebra. So share this, please. And Toni, I see we haven't got the slideshow on yet. Toni's working.
I was hoping that you would have it because I have shared it.
Shared it on WhatsApp?
Not on WhatsApp, on this scheme.
No, it's not. It's not on. Not yet. But we always find a way because we are.
Let me do it again. Let me try. Right, I'm going to try again, Caroline, because it didn't seem to work that time. So let's try once more, and let's have faith that this time it will work. Share.
I've got lots of faith, Toni.
Well, it has worked before, so why isn't it working this time?
Got everything crossed.
Can you see it?
No, I can't. Do you want to leave the studio and come back in? Sometimes it just needs kind of a complete reset.
Yes, well, it has worked before, so...
yes, it has, no question.
Let's try again. So I'm going to cancel that. Leave the...
I seem to... Oh, yeah, she's leaving the studio. I think we had this problem last week, actually. It took a little while for us to get started last week, if I remember correctly. So she's going to come back in a moment now. Toni will be back with Algebrarea. Algebrarea being a way of looking at area, and talking about which, I better get my my visualizer set up, because I'm actually going to be doing a puzzle today. No, I haven't tested to see if my I think we used it last week, so it's going to be all right. Toni isn't back yet. Oh dear. Well, let's see if this is going to work anyway. Share. Oh, Toni's back. Toni's here. Oh, add her to the stream.
Share again.
Okay, we're going to have another go.
That was this time, Caroline. Is this that you want to share?
We've got someone's crying. Someone's watching. I've got a sad face on.
Well, no, I'm not crying, but I'm very.
No, you, Toni.
It says StreamYard.
Yes.
Is sharing your screen. Is that right?
It's here. Yep, it's here. It's arrived.
Oh, absolutely great. Right.
An emoji, Toni. Someone's put a crying emoji because it wasn't working.
Well, thank you for crying for me, because I was almost on the verge of tears, but here it is. And what we're doing is a puzzle, and we pick up from where we left off last week, but it will, for those of you who weren't with us last week, it doesn't matter, because it'll make sense from this point, because we're going to sort of start again. It's a puzzle. It's fun. It's just like doing any puzzle. And what you've got to do is you've got 10 little pieces there, and 2 blue and 3 green, and the other we'll call peach. I don't know. It's a funny color. There are 5 of them. And the puzzle is to fit them in to the big outline on top, the frame there. So they all fit in neatly. And you've got to join them edge to edge. And X can be anything. That's just why we call it X. So it can be bigger than 1, it can be smaller than 1, but in this case it looks bigger than 1, because what you see is the small green squares are 1 unit by 1 unit. So if you look at if you can see this, if you've got a square that's 1 unit by 1 unit, its area is 1 square unit. There's bigger squares, they're in blue, and they're X units by X units are the measurements of the edges, and therefore the area of the blue squares is X squared square units. And we've got the peach pieces, they're rectangles, and so that they will match. The shorter edge matches to the unit square, because it's length 1 unit, and the longer edge matches to the blue square, because that's length X units. So, Caroline, are you going to demonstrate this?
I do have it, but what I would like to say is what I said last week, because some people, as soon as they hear the word X or the letter X, they switch off. Gone. It's literally, it's like an off switch. All the X means here is we don't know the length, or even that the length doesn't matter. So we're calling it length X. It's like the X, the X factor. We don't know who's going to win, or the X-Men. I don't know. I suppose they're a bit different. They kind of got special powers, but all that the X is we don't know its length, and it doesn't matter what the length is. It's just different. Yeah, exactly.
And it's a gateway into algebra. So what we're doing is linking multiplication, because you multiply the lengths of the edges, to area. So you get the area of the shape by if it's a rectangle, by multiplying the length by the breadth, and then we link that. Then we will link that to algebra, and we'll do that later in this hour. So, Caroline, are you going to show people how these fit together?
Yeah, and I just realised that I have committed a slight boo-boo, that presumably when I printed in colour, the printer colour wasn't working right. So I ended up with some yellow ones, because I thought there were 4 different colours, but no, there's only 3 different colours. So I've just sorted it. It's all sorted now. So let's write.
So I'm going to stop sharing, Caroline, so that you can do your demonstration. You can show everybody how this works.
Oh, I've just found out how to do. I don't know how I did it, but share screen, application window. And it's not one of my options. So now it's my turn to wonder what on earth I'm doing here, Toni. Let me see. It doesn't come up with my visualizer as one of the options.
Well,
if maybe it's camera. Maybe I can choose a different camera input. And now I've got the whirling whirligig of death. I can't do anything.
Well, I mean, if you want to just to carry on, we can do that.
You better just carry on for a moment, Toni, because at the moment I've got a thing. I literally can't close the screen, anything. So yes, please carry on. And oh, I've managed it. My entire screen, application window, and that's not one of the possibilities. That is really frustrating. If I share my screen, that's doing what yours does, and if I now put the visualizer in, does that show it? You can't see my visualizer, can you?
No, I can just see a lot of different stuff on your screen.
Yeah. Okay. It's not working. I don't know how to do it, so I can't do the visualizer. Did I manage it last week, Tony?
I don't think you did. I don't think you've done it on
StreamYard.
No, I don't think so.
Okay. I shall have to experiment. Okay. All right, Tony.
Have you got this back? Have you got mine back?
No, yours is not there.
Oh dear. Okay, so let's try again.
I think we had problems with this last week. Oh, here we go. Here we go. I can see it. We got it back. You're back.
Right. Okay. Well, Caroline was going to try it just to show you. So what we do with the children, and it's fun for adults, families can do it, parents can do it with the children, is to print out the sheet. And we'll tell you about the link to, perhaps Caroline can get it to go along the footer of this, the link to the Aiming High website, and there you'll find an inclusion and home learning guide. And this will give you a sheet that you can print out, and then you can do the puzzle for yourself. So what you do is you cut out the 10 pieces, and then you put them into the big rectangle, and that's as we said, that's it. And then we ask the children to draw other shapes which are not rectangular, but by just putting these pieces together so that the x's match the x's and the units match the units, and write down the areas that they get. So, well, we're going to move on to think about this process of linking multiplication to area to algebra. But just a bit of a diversion first is we've got to know what these brackets mean, because we're going to use brackets. And how do we do the arithmetic of adding and subtracting and multiplying and dividing? And when we put brackets into this list of numbers, what do the brackets mean? And there's a little sort of word that is often used. Think about it. You may have met it in a slightly different form. I got this wrong when I was typing it in. I should have put BIDMAS. I should have put a D for division in there, and it didn't somehow get typed in.
Most people have said BODMAS, haven't they? Most people.
Well, I don't like BODMAS because I don't know what O means, but I means index, which is power. What does O mean, Caroline? Order, I think.
Or perhaps I'm going to Google it.
Yes, so people are very vague about that.
I've never used BODMAS. I've always that's the one thing that I really do understand, and I've never used BODMAS. It's orders. As instead of index, it's used. They're referring to them.
Yes,
as orders.
but I mean, orders isn't a mathematical word. It means putting something in order from smallest to biggest. It doesn't mean the power. So I think BIDMAS is better than BODMAS. But anyway, what we want to do now is to match the expressions on the left with the values on the right. Can we work out what we've got here? So why don't you do the top one, Caroline, and see which of the ones under the values column it matches to.
Okay. I would say it's. Do you want me to actually say what I'm thinking? And we'll go through the process. So what I've done is it's very simple because it's just numbers. I've just done 7 plus 2, which is 9. And then I multiply that by 5 plus 3, which is 8. So it's 9 eighths. Now, the way I work out 9 eighths, I don't have it memorized. I know it's 90 minus 8. So it's
80
not
minus
90,
8.
80 minus 8. 10 times 8 minus 8. So it's 72.
That's it.
That's
okay.
Yeah.
And the next one is 9 times 5, which is 45, plus 3, which is 48.
Yeah.
What's the next one, Caroline?
So the next one is the key operation is in the center, 2 times 5, which is 10, and then you're adding on another 10, so that's 20. So that multiplication, you're adding together 3 amounts, the middle which of is 2 5s, as opposed to, instead of writing 10, it's expressing it in terms of 2 5s.
Well done. So that's your 20. And the bottom one, you've got your 5 added to 3, which is 8. So you're doing your brackets first, and then you multiply by the 2, which is 2 times 8, which is 16. And then 16 adds 7 is your 23.
And the way that I do that, again, as I say, I don't remember BODMAS. I do not remember. I wouldn't be able to remember it, even if memory is not my thing. So I have to understand how this works. So the key is you've got 2 of something. You've got 2 of them. Whatever it is 2 of them. Whatever's inside that bracket, you've got 2 of them. And what happens to be inside that bracket is 5 plus 3, which is a very simple 8. But you've got 2 of that, which is 8, and then you add the 7. You don't have 2 of the 7, and it's not just 2 of the 5, it's 2 of the 5 and the 3.
Yes, but you will get into trouble if you do your addition before your multiplication.
Well,
so you really do have to remember that.
Yeah.
No, but you really do have to remember that the multiplication comes before the addition. Now there's a
hold on, Toni. Now I'm confused, because if you go back to that one, I can't do the I can do the multiplication by opening out the brackets, but expanding the brackets. But I'm adding the 5 and the 3 before doing that multiplication, because the 2 times.
Caroline, Caroline, where are you adding your 5 and your 3? At the top, the first one. Because the last one.
First thing I'm doing is adding the 5 and the 3.
But that is all lumped into a bracket. It's adding the 7 that must come later.
But that's how I remember that I've got to, because the bracket, it's like I've got to do what's in the bracket so that I know what to multiply 2 by.
So you do the brackets first, that's the 8, and then you multiply by 2, which is your 16, and then you add your 7. So it isn't going from left to right as you do when you read something in a book. If you're English and not Chinese, you read from left to right. Here you do the BIDMAS thing. You do the 8, and then that's what's in the bracket, and then you multiply it by 2, which is your 16, and then you add the 7. So I think we're going to need a break now, Caroline, because we've had our first 15.
Thank you. Okay, so after the break, briefly.
After the break, we're going to do more of the Algebrarea.
Okay, so this has been what people are familiar with, and we're going to be looking at more pictures, and those pictures are so powerful. After the break, the power of the pictures.
It's time for a show on Relax Radio. It talks about me and you. It's time for a show on Relax Radio. It talks about me and you. So listen to us here 24 hours and let the happiness come to you on Relax Radio. Tune in to Relax Radio. Relax Radio.
Now, Caroline mentioned the power of the picture. I like that, Caroline.
I've gone and got my glue as well. Since my visualizer isn't working on StreamYard, I've gone and got my glue so that I can actually create the puzzle for real. So yes, the power of the picture.
Okay, so the power of the picture. Now here, if you remember, we were talking earlier about having those 10 pieces and fitting them into the frame. And here you've got the solution. So your area, the green ones that are all of area 1, you put them side by side, and then that area is 3 square units. So it's 3 times 1, and there you have it, 3 square units. And then the peach ones, you do this in 2 parts. So you have got, so you've got your 2x times x, if you like, in the area, but each one of them is area x squared, because the area is x times x, and you've got 2 of them, so it's 2x squared. So
I've got an x squared plus an x squared, which
giving
is
you a
simply
2x squared.
It's just like having 2 ones. It's 2 times 1. So it's 2 times x squared.
Yes, but be careful. It's 2x times x, which is 2x squared. And now you see, if you're able to see this picture, what you've got is in blue. It's the 2x squareds and when you put them into the solution of the puzzle, they sit side by side. And then the x edge is married to the longer edge of the peach bit. And so where you've got your 2 blue squares above them, you can put your 2 peach rectangles, because those x edges match. And you have got 2x times 1 there, giving you your that area, which is 2x square units. Now you have to turn the other peach pieces round through 90 degrees so that their long edge matches the other edge of the blue, and their short edge matches the green squares. And there you have 3x. The area of each one of the peaches is x, and you've got 3x. Now, altogether, of course, there are 5 of those peach pieces.
So far I've got this. I've labelled them slightly differently to you, so you can see we've got 2 times x squared. Each of these are x times x squares, and then these are x times 1. So one edge is unit length 1, and the other edge is length x. So 1 times x is still x. 1 doesn't change the number. So whatever that mystery number is, it doesn't matter what it is. It means it can be any number. It's just x. So each of these are x's. So you can actually count how many. You've got 3x there plus 2x there.
Yes, and so finally you get 2x squared plus 5x plus 3. Now, if you see, we sort of got ourselves quite a long way into algebra just by matching these, putting these pieces together in this way. And the bridge was the idea of multiplication, because when you do it purely numbers, you're multiplying how many there are in each row by how many there are in each column, and that gives you the number of units, and that's your area, the square units. Here you've got your 10 pieces, and they go together, and you can see that 2x plus 3 is 5 times x plus 1 gives you 2x squared, and the 2x and 3x make 5x, and then you've got the 3, and we've put them in the 3 different colors. So we've got something really neat there that takes us from just a simple puzzle, and it takes us into something quite complicated, which is this multiplication of the 2 expressions, each of which have got in brackets, and the 2 brackets, each of which have got 2 terms. And the first term in the first bracket is 2x, and then add 3 to that.
Which is these 2 here. There's your 2x. No, it's 2x squared. That's your 2x squared there.
Oh, and Caroline, can people see what you're doing?
Yeah.
Oh, I see. Good. I can't, you see. I'm not able to see it.
Yeah, people can see what I'm doing. So we got the 2x squared. The first one is the 2x squared, or are you looking at the blue or the peach?
No, Caroline, we're looking at the line above. We're looking at the first bracket, and it's got 2x.
Okay. So yeah.
We're looking at the algebra, and it's
so
2x plus.
That's the 2x.
2x plus 3 in the first bracket.
And there's your 3.
You've got 2x times x, which gives you your 2x squared. And that's the blue area, in which is the rectangle in the solution, which is 2x times x. And then you've got 2x times 1, which is the area on top of the blue, 2x times 1 in the solution. And so if people can see my screen, they can see that you're doing 2x times x, which is 2x squared, and 2x times 1, which is 2x. And then, this is the algebraic process, they do 3 times x plus 1. So they do, first of all, 2x times x plus 1, and then it's 3 times x plus 1, which is on the left, which is your 3 times x, which is your 3 peach pieces, area 3x square units, and then 3 times 1, which is your 3 green squares. And finally, you put the 2 pieces in the middle together because they're all the peach pieces, giving you 5x. So you've got 2x squared plus 5x plus 3. So you move from the pictures right back now into the top right-hand part of my screen, and you see what you're doing is multiplying your 2 binomials. Now, why is this conservation of area written there? You see, when the children are doing the puzzle all along, really, but from the very early age, when they're solving this puzzle, it's just fitting these pieces into this big frame, what they're doing is realizing they're not stretching those pieces, and however you separate it into little bits or put the little bits together again, you are keeping the same area. You're conserving it, as we mathematicians call it. So what we're doing is we have to understand in the mathematics that we're not changing the area, and we are not changing what the maths tells us when we piece it together and we pull it apart and we piece it together again. So quite a lot of manipulating those letters and numbers in algebra. And that's what you're doing. If you just look at the box at the top now, this is pure algebra. All you're doing is putting the pieces together as you did in the jigsaw puzzle.
So basically, by expanding brackets, you're not actually changing the substance of it. You're not changing the rectangle. You're only changing the way that you're breaking it down into smaller pieces, but the rectangle is still the same. The outer border, let's say, it remains the same. And it's important that you don't change. Whatever you do, you've got to do it. Like if you wanted to get rid of the 2, as they say, on the top, you would divide everything by 2. So by doing that, you're not at the top and bottom. Basically, you're not changing it. If you only ever, whatever you do to it, that rectangle must stay the same on the outside.
So
the top and bottom of it. And that's why it's so important that you're not doing weird things like adding things and just to be helpful when it doesn't work.
Well, I think what we need to say here is that the whole point of all of this is that algebra is you mustn't move on until people really understand what's happening. And often this multiplying of the 2 binomials, these 2 brackets together, is taught as these are the rules, this is how you do it. And if you do it the right way, you'll get the right answer. And the children really don't understand it, and then they don't remember what the right way was. And algebra then becomes something that's confusing and difficult. And as they go on doing more of it, they just get into deeper and deeper water. So what we're trying to tell you here is that the best way to get your head around algebra is to make sure that every step on the way you actually understand what you're doing. And here what we've done is to make this process of multiplying the two binomials together, and we're breaking it down into the little pieces, putting the pieces together again in a puzzle, and then seeing how the areas fit and why you get the result of 2x squared plus 5x plus 3 at the end of the game. And I think after the break, we will move on and build on this basics.
Okie dokie. And so get ready. If you're working along with us, then a pen and paper would be useful to actually work things out as well.
It's time for a show on Relax Radio. It talks about me and you. It's time for a show on Relax Radio. It talks about me and you. So listen to us here 24 hours and let the happiness come to you on Relax Radio. Tune in to Relax Radio. Relax Radio.
Right, well, we're going to
welcome
move
back.
on. We're going to move on, and we've got the two blue squares, which are the 2x squareds in area, and we've got the 5 peach coloured, and that's the 5x in area, and we've got the 3 little green ones, each of them 1 unit, so they make up 1 unit, 3 units of area, and so we've got 2x plus 3 times x plus 1 is 2x squared plus 5x plus 3. Now then,
Sorry, Tony, I've worked out how to put my camera on if it should be useful.
well,
I've had
I
to
think
visualize it on.
I think now, Caroline, we'll do this another time. We'll do the visualizer
Okay.
another time.
I've worked out how to do it.
Because I think we want to talk about now introducing algebra, and now here I think this simplifies what we were just doing, because what we're seeing is how 2x plus 3 times x plus 1 and the 2x plus 3 is split apart into the 3 on one side and the 2x on the other, and we have got the 1 plus x or x plus 1 there as well. Now, what are these key questions? They're really important, because what we do, the good teacher does, is to give the children activities, give the learners activities to do, and then to build on what they're actually doing, their own activities. So can they make a rectangle with the 10 pieces? That's another way of asking them to fit them in the frame you just saw. Just make them into a rectangle. Maybe that's a simpler thing to ask them to do. And can you subdivide the rectangle into 4 simpler subunits and find the areas? 4 simpler, a subunit is part of a bigger unit. So maybe the word unit, subunit is a bit confusing. 4 simpler parts.
Maybe we area.
We should have just used the word parts there and find the 4 areas, the areas of the 4 parts of it.
Yes.
I think that's better. And then you've made some different, when they've done it, we are going to ask them to, you've made some different shapes using the 10 pieces. Do you notice anything about the areas? And what you want is that the areas are always going to be 2x squared plus 5x plus 3. However you move them round, the total area is going to be 2x squared, 2 blue ones, plus 5x 5 peach ones plus 3, which is the 3 green ones. And I think then we should be reinforcing these ideas by going back a step and doing it with something that's more concrete, if you like, they've been working with the numbers for many years before they reach the algebra. So let's go back and do it with the numbers. And here we have with the numbers 34 and 28. 34 times 28. And this is what people call long multiplication. And this is a great way to do multiplication. So we've got the tens and the units. We've got the 30 is 3 tens and 4. 34 is 3 tens and 4 units. 28 is 20, 2 tens and 8 units. The whole process of arithmetic is based on what we call place value. And the long multiplication, this shows so beautifully how long multiplication is broken down into simpler steps.
It takes the mystery completely away from all they take this and carry one and why am I putting that one there and what am I adding again? It just takes that whole mystery away and just makes total sense. So you've got 20 30s, you've got 30 of something and there's 20 boxes of those. Well, how many have you got? It's a lot more than, certainly not 60.
So what you've got to think about there is this 30 in a row going across, if the other units, right? And there's 20 rows. So how many units are there altogether? 30 by 20 is your 600. And then you've got 4 in a row in the thin strip. And you've got 20 rows. So how many altogether? 4 times 20 is 80. And when you come down to the 8 of the 28, you've still got to multiply it by 30. And there's 30 in a row, but there's only 8 rows now. So that's 240 more units. And then 8 by 4, there's 4 in a row, and there's 8 rows. So you've got 32 units there. So we're looking at tens and units, and we can imagine breaking the tens down into units as well. And that takes all the mystery out of long multiplication.
Yeah.
Isn't that nice? So now let's jump back into algebra. And doesn't the algebra seem simple now? You see, algebra, the reason we use these P's and Q's on X's and Y's and R's and S's and then other letters too, is that we're dealing with something that we want to be what we call a variable. We want it to be changing. And as it changes, things are happening that we can think about, and we can learn a lot from watching the algebra change, watching the variables change. And one place we actually watch them change is in the graphs. So imagine in your minds now, you've seen graphs, seen also different graphs in different places. And as you move across your picture, we usually call that the X direction. Things are changing as X changes. And as you move up and down, we usually call that the Y direction, and the Y is changing up and down. So the graph is your all-in-one picture of how things change as you change X and as you change Y, or as you change them both together. And, well, your graph could be a straight line. It could be a nice curve of a parabola, like the shape that you get if you throw a ball in the air. That's a parabola. And you can have other graphs. You can have statistical graphs too. same thing. Your statistical graph might be some going across is the date, right? And it's as the dates change, as you go through the weeks, as the dates change. And on the graph that goes up and down, that could be something about the number of cases of coronavirus or something. But as you see, the shape of the graph now isn't it, well, you hope to see it going down, don't you, if it's what I was just talking about. But we've had some scary patches.
The number of children that are able to go to school each year, and then we want that to be increasing, for example. Getting a good education.
Yes. So let's come back to number 5. Supposing you need to multiply P plus Q by R plus S, and P and Q are our magic variables from which we can find out so much when we study them a bit further. That's why algebra is so useful. It's why maths is so useful in many hundreds of thousands of applications, millions of applications. So it's all because of the power of variables. So P, Q, R, and S are variables. So it doesn't matter at the moment what we're just having to fix them to draw a diagram. But we're going to multiply P plus Q by R plus S. And the same way as we multiplied 34 by 28, we do the same thing again. And in our diagram here, think about rows and columns, we've got P in a row, P whatever they are in units in the row, and R row, so the area is PR. And below it, you've got the area of SP.
So PR meaning P times R. You just don't have to put the times table. That's the way it's done.
Yes. So that the whole thing looks prettier. You don't put the multiplication sign in because you know that whenever you have these two letters in algebra together, then without anything between them, it means that they're multiplied. And then you've got a rectangle which measures R by Q, R one way and R up and down and Q right and left. And when you work out that area, it's RQ. And you've got another one which measures Q across still, but now it's S up and down. And that rectangle is, if you want its area, you multiply S by Q. So what we've done here, we've linked the whole idea of multiplying and in rows and columns, and then we've linked it to area to find how many you've got all together. We had a marching band and people in a picture last week of people in a marching band, remember that? And that we counted how many rows, how many in a row, and then how many rows there were. And that is a quick way to work out how many people all together, not counting them, don't need to count them one by one. And you're doing the same thing in algebra. So I think we're time for another break now, Caroline.
Okie dokie. And after the break, we're going to be...
Well, we'll talk a bit more about key questions, yes, and how to use them in assessment as well.
Brilliant. Key questions, so powerful.
It's time for a show on Relax Radio. It talks about me and you. It's time for a show on Relax Radio. It talks about me and you. So listen to us, 24 hours. Let the happiness come to you on Relax Radio. Tune in to Relax Radio. Relax Radio.
Okay, so we're back. Yes, we're here, Toni. So we're back with the final 15 minutes of Happy Maths Hour.
Well, now we think about a key question is what we were asking before. But if we say to the class now, they've done a lot of examples, and now we say to the class, suppose you need to multiply 3x plus 2 by 5x plus 3. Now, what we want them to do is not just apply rules that this is what she told me to do, and I'm going to do what I did before in a way of, I'm going to multiply 3x by 4x, and then I'm going to multiply 3x by 5, and then I'm going to multiply 2 by 4x, and 2 by 5, and I'm going to add all that up. We're actually suggesting, suppose you need to multiply those two expressions in the brackets. They're called binomial expressions, bi meaning two things in the bracket. Show me what you would draw to find 4 areas that give you the product of the two expressions. So when you multiply one thing by another, you get a product. And so here the question is, show me what you would draw to find 4 areas that give you the product of the two expressions. Now, you will see that is a key question in the sense that if they can answer it and do it as we did the other examples, the learners will show you that they really understand this process. And that is what's important. Not that they can actually do it and get the right answer, because a machine can do it quicker and doesn't make mistakes. That is not what you want to teach children, just to be able to do something, turn a handle, do something by a sort of rote method and get an answer. Because in this modern world, that's not valued anymore. Machines do that. What do people do? They have to be creative with the ideas. They have to be able to apply the ideas and use the machines to actually do the working out. Okay, so now the next step was, what might we need this for? Well, this is a very, very sort of simple little example, but here we're going to be thinking about solving a quadratic equation. So what we're told is the area of the rectangle is 66 square meters, and you've got to find x. You might have been asked it in a completely different way and given x and been asked to find the area. But this question is sort of turned on its head, and you're given the area and you're asked to find x. Now, so we now know how to multiply 3x plus 2 by x plus 3 by the process that we've been talking about last week and this week. We're bound to get 3x squared plus 11x plus 6, one way or another. And what is the question actually? What information have we got in the question? Well, we know that the 3x squared plus 11x plus 6 is a way of talking about the area of that rectangle. And it seems to be that it's a rectangle that's being drawn around a dam or a stretch of water. And we know that's 66. So we have to solve the quadratic equation. And so the process of solving that quadratic equation, well, there are various ways of solving quadratic equations. We've got a long way now. You see, what we've traveled from is, last week we were talking about little children playing with rectangles and squares and talking about them, and then slightly older children in primary school fitting them together into a rectangle, and then introducing the idea of algebra, but linking multiplication to area to algebra. And now we're solving quadratic equations and applying what we knew to something else now. And now, if we've got the 66 on the right, we know that quadratic equations, your upper secondary students know that quadratic equations, you've got an x squared term and an x term and a constant term, and you put it all, you tidy it all up, so you've got whatever is scattered around, collected together in a nice, neat form, which is the x squared term, the x term, and the constant term equal to 0. And this time it's the x term, the x squared term is 3x squared. You've got 11x, and you've got the minus 60 as your constant term. And then you've got to find a way to factorize this. And there's various ways of doing the factoring. But if you notice that you could split your 11x up in, or break it into, or imagine it as being formed in several different ways. And here, that one way that people often do this is to say, well, we do know that it's going to be 3x times x when we come to factorize this. You see, it's not the same two brackets as we had at the beginning. Now, having put the 66 in there, we've got to go in the opposite direction. So we're going from the trinomial, which is 3x squared plus 11x minus 60, and we're now going back to putting this into what two things would we have to multiply together to get back to our two binomials. And well, I don't think we want to labor through how we understand the factorizing process. There's a lot of trial and error involved in that. But we finally find that it's 3x plus 20 and x minus 3, because we are looking for something times something to give the 60, and it's minus 60, and it's 20 times minus 3. And we're looking for something times something to give you your 3x squared, and it's 3x times x. There's only one way.
It can't be anything else.
No, exactly. Yeah, it has to be 3x times x. So really the whole key is, how do you break down the 60? And well, it could be 2 times 30, 3 times 20. Yes, it could be 5 times 12, and it could be 6 times 10.
But then you wouldn't get your 3x squared, and you wouldn't get your
so you've got to get the middle term right, and there's a lot of trial and error in that.
Okay.
Now, when you've got your two things multiplied together to give you 0, one or other of them has to be 0. If you're going to get 0, one or other of them has to be 0. Now, if 3x plus 20 is 0, that means 3x is minus 20, and x is minus 20 divided by 3, and that can't be the answer here, because we're talking about lengths around this fencing, around the water, okay? So we've got to have a positive value of x, so the solution is x is 3 meters. And don't worry if you don't understand how to do the factorizing. What we're really trying to say is that you can do this, you're involved when you're doing factorizing in going back from a trinomial expression, a quadratic expression with square terms,
trinomial.
Into two brackets.
You've used 3 words. You've used binomial, trinomial, and another one. Could you just very quickly explain what those mean?
Binomial is something with 2 terms, and trinomial is something with 3 terms.
So 3x squared plus 11x plus 6 is a trinomial.
Yes.
And even if that were 3x to the power 10 plus 11x plus 6, would that still be a trinomial?
Yes, but it would be yeah, well, this is where we were talking about earlier. Yeah, I suppose we would have called this the power 10 there. Okay.
The power 10, okay.
Yeah, so what we're talking about is a quadratic expression on the right, isn't it? Because the highest term is power 2.
Okay, so it's a quadratic, and then it's a trinomial because it has three separate
terms. It's got three terms.
And if it had four terms, let's say if it was 6 plus 10, that wouldn't be a term, because you want to combine those in order to establish whether it was a trinomial.
Yes.
You wouldn't call it a trinomial until you combined all the similar terms.
But supposing you had an x cubed involved in some expression, and so many x cubed plus so many x squared plus so many x plus a constant term, that would be that wouldn't be it. That would have four terms. There isn't a particular expression for that, but people do talk about binomials and trinomials for some reason.
So the binomial would be the 3x plus 2.
Yes.
It's only got two terms in it. Okay. Just to make sure we're clear on that. Okay.
And then we've got 3x plus 20. When we solve the equation, we find that it's split. Our trinomial is now being, our trinomial, which was 3x squared plus 11x minus 60, has been put into two binomials, and they're 3x plus 20 and x minus 3.
Right. Okay. Right. Okay.
Right. Let's wind up then, Caroline. We've had a journey, haven't we?
Well, yeah. You asked how you draw it, and I've drawn it. I drew the other one that you had. It was 4x plus 5 times 3x plus 2 is not to scale. Absolutely not to scale, but I did draw it. There you go. So it doesn't have to be a very precise, pretty thing, as you can see. But what you've got, you can then count. I can count that I've got 10 actual numbers that aren't, what do you call that? It's just a digit, 10
units.
10 units, and I can count how many X's there are, boxes with X, just that I've got 8 there, and I've got 15 there, that 8x and 15x, and I can count how many x squareds there are. They're right there. And right. So yes, I did that. I just thought it might be helpful for people to see that you can just draw it. And you did say do it, and I did it.
Great, Caroline. Well done. Good. So I think our time is up. It's 6 o'clock here.
It's 2 minutes to, but that's grand. Thank you so much, Tony. Oh, AIMSEC. Just we're going to put the fundraiser on. I was in the Mindset Monday. I was talking about that I'm going to be doing some fundraisers for AIMSEC. That the website, the Amy High website, is where you get all these resources.
And it's all free. All free. No charge. but it isn't free insofar as a huge amount of time and effort goes into it. We have a team of people working who are actually doing empowering teachers who teach in the poorest of the poor areas in Africa, where they've got living conditions are not good, but people are very cheerful and they don't complain a lot, and that's what I find. And what we want is the children to be able to get a good job when they grow up and maybe have a chance of a better life. And so what I do, and my team, AIMSEC, does, is to try to give the children a better life because they get a better education. We empower the teachers to give a better education by training the teachers, by helping the teachers. And that is where we're looking for donations, because we have, but to do it, we have to spend some money. A lot of people are working for nothing, right? Nothing. Yeah. But there are we have got a team of people in South Africa who we have to employ in order to make it all possible. And physically at the moment, there are 90 teachers on the course, and it's a 3-month course. It's all online, and we're asking for people to donate. So a lot of people are benefiting from all the free resources, and we hope that they will appreciate that they're getting something for nothing, and they could give something back by helping us a little. You don't have to give a lot of money. If you've got a lot of money to give, that would be fantastic. But even if everybody who uses our resources gave us a little bit of money, it would add up to something which would help us a lot.
Thank you so much, everyone. Thank you for persevering with this. If you only saw the end of it, go back to the beginning, because it starts off simple. And if you watched last week's show as well, it starts off super simple for early years. And we're building up with this. And the idea is it's stepping stones. And if you go to the resource on the website, on the Aiming High website, then you have the home learning guide, which takes you from the beginning, from the 4-year-old all the way through to the 18-year-old. So use it, Aiming High, and search for Algebrarea. See you next week. Thank you so much.